Yeah, so thank you for joining in. My name is Edward. I'm working as an open science methodologist at the Brain Heart Interconnectome. So today's talk will be talking about research data management with the focus on preclinical studies. But the discussion here would apply to a broader audience. So anyone's interested in like research data management, this should apply to you as well. And at the beginning, we acknowledge that the work of the BHI research program takes place on the traditional, unceded, and ancestral lands of the Algonquin and Anishinaabe people. We recognize their long-standing relationship with this land, which continues to this day. We strive to incorporate indigenous knowledge and perspectives in our research and aim to contribute to the advancement of health and well-being of all communities, particularly those who have been historically marginalized. And for this talk, I will start by introducing the key principles and the policies of research data management. And then next, I will talk about the data management plan. After that, I will cover the best practices in RDM. And finally, we will discuss data management in the context of a data set from a BHI group. So what is research data management? Research data are defined as any type of evidence that is captured as part of the research process or evidence used to validate the research findings and the results. Research data can be in a variety of forms, including temperature data, images, videos, etc. Research data management is all about the steps taken during research project cycle to handle the data, how it's collected, documented, stored, shared, and preserved for future use. Effective research data management relies on a set of guiding principles. So here, I'm going to highlight two key frameworks that set the standards for data management, the FIRE and the CARE principle. The FIRE principles provide high-level guidelines that are intentionally flexible, making them domain-independent and not tied to specific hardware or softwares. It specifically addresses the needs of today's digital world, where the digital data is often generated and read by machines. So this means that the data must not only be understandable by humans, but also machine actionable as well. By adhering to the FAIR principles, researchers can enhance the reusability of their data, thereby supporting reproducibility and facilitating the sharing of knowledge. And the CARE principle stands for collective benefit, authority to control, responsibility, and ethics, meant to complement the FAIR principles, providing key guidelines on ways to work with indigenous individuals and communities and the data that describe them. Research data management is also an integral part of government policies. The 2021 Tri-Agency Research Data Management Policy has a few implementation components, which may require changes in the daily practice by research institutions and individual researchers. So for certain funding opportunities, starting spring 2022, the requirement for the data management plans will be gradually rolled out. And so we will talk about the data management plan in detail. And the data deposit requirement will also be phased in after a review of the readiness of the Canadian research community, and is expected to be phased in 2025. And this is an up-to-date list of grants and the fundings provided by agencies that require the submission of data management plans at the time of application. So what is a data management plan? It is a living document that details how you will create, store, organize, document, secure, preserve, access, and share your research data. It can help for your ethics approval. It can reduce work and minimize any data-related problems. And it prompts researchers to consider every aspect of data management that they may not consider in advance. And in return, it leads to improvements in research plans and methodologies. So research data management is not only something you need to plan ahead and discuss when you are doing the data sharing deposits, it is something you always need to consider throughout your research process. And the formats and the content of the data management plan includes what and how data will be collected and used, how data will be documented and formatted, how and where data will be stored during the research project, where data will be deposited for long term, how data will be shared and reused, and the research team's roles and responsibilities regarding the handling of data, and also ethics, legal, and commercial considerations for the data. So in this seminar, we will talk about a lot of these aspects in detail, which will help you to draft your data management plan for the next project. So to prepare for DMP, the Digital Research Alliance of Canada, which is funded by the Canadian government, has developed a national tool named the Protege DMP Assistant. It is bilingual, free to use, and include available templates with work examples. It works quite effectively. Generally, it's not very specific. It's just it applies to your research projects in general. And locally, the Meta Research and Open Science program at the University of Ottawa Heart Institute have created these specialized types of DMP templates, including clinical trials, systematic reviews and meta-analysis, preclinical animal studies, and genomic data. So these have been created and validated by researchers specialized in this 4 area and provided as resources. So if your research is related to these areas, please feel free to reach out, and we will support you in this regard. And now let's take a look at the best practices for the research data management. So first of all, let's take a look at the file formats. For depending on the type of data, the formats can be proprietary or open formats that you're using. And we always prefer the open formats because the softwares can be outdated and people need to, there's a cost associated with proprietary software. And so open formats is really something that's ideal for sharing your data and keeping your data for long term. And generally, how should you name your file? So the consistent and clear file naming is so crucial to make sure your files are easily identifiable, accessible, and reusable, especially when you're collaborating with others. So it is very important to include a unique identifier in the name of the files, for example, the grant number or the project name. And also you want to use clear and descriptive names for the name of the projects or the name of the research data. You also want to include some details of your experimental settings, for example, the equipment used, the organism used, the temperature, condition, etc. And especially if your data is very data sensitive, and make sure you include your data in standard format. So the ISO 8601 format is a standard format that's being used, year, month, and date. And for your files, try to avoid these special characters at all costs. They generally generate problems when you share the data. And then there's shouldn't be any spaces in the file naming as well. And you also want to include the version numbers as the data sets are being modified. So it's very important to be consistent and create a rule and stick to the rule. And now let's talk about the file versioning. So this is also a crucial step in data management. So proper versioning help you to track changes and help you to collaborate effectively and avoid confusions. So always use a version number in your file and include the date if it's time sensitive. And one of the good practices is to have a change log. So to the right, here's an example of a change log. So you include each version number and the release date, and you categorize the changes, and you describe the changes, and you also add who made the change, the authors or contributors. And it's always it's much easier if you can use like a version control software. So we highly recommend it, like open science framework, which has lots of built-in features to help throughout the research data management process, and also Git technologies like GitHub, GitLabs, that you may have already familiar with these tools, and can also track the versions of the files as well. And to the top right is a format for showing the version number, like 6.2.3. The first number shows there are some major changes. The second number, if you update that, if there are some minor changes, and if there's just like some small patches, then you change the third number. Okay, and then let's talk about the file conversion. So a lot of times you may need to change the files from one version to another. For example, let's say from a PNG image file to a JPEG image file. And during this process, the information may be lost. So you really want to document the conversion steps. And if possible, you want to keep the original file along with the converted ones. So just make sure that no information is lost in the process. And then now I just want to go through like a few tips on organizing tabular data, because tabular data is so common in the preclinical area. So first of all, so when you have the tabular data, you really want to use your contrast effectively. So to the top on the left, you can see like the titles are being shaded to clearly show that they're titles, not the data themselves. And you do not want to encode your data in font or colors because it can cause a lot of confusion. Let's say you color this cell in red. Other people may not know like what that means. Is it something the data is wrong or is out of range? And also, it doesn't readily support analysis. So when you're using other software to analyze this file, it wouldn't pick up on the color of the font in the file. And for the alignment, you really want to make sure like all the numbers or text in the columns align well with their label headings. And in terms of ordering, you want to place items that are similar to one another together in your table. So it's generally very good practice to only put like one value in each cell. So to the right, you can see like there's several values on the same cell, which can cause a lot of confusion. And spacing, you really want to have sufficient white space around all the values in the label. Again, here we can see that there's several different informations within the same cell, which is highly unrecommended. And again, you only want to put one piece of information in each cell to minimize misinterpretation of the data. And you want to use consistent labels across your data. You don't want to switch different spelling or encoding. So here, let's say for sex, if you use male, female, you use a word. Try not to use letters and big letters, small letters. That's going to cause a lot of confusion. And just a few other tips. And you don't want to leave any empty cells. And generally, if the data is missing, do not use 0 because it can lead to misinterpretation. So the common convention is to use -99, and always document these codes in the metadata and the code book you use that are associated with the data. So these are like some small tips, but it could be very helpful because most researchers are handling like tabular data on a daily basis. And to clean up tabular data can be quite tedious and time-consuming. So these are the tools available to simplify this task: OpenRefine and the Grail. So if you're interested, please check it out afterwards. I will share the slides. So next, I'm going to talk about the data security and the backup. So data security is a crucial aspect of research data management, especially when handling sensitive information. So now let's go through some of the key strategies for managing data security. The first step is to create a comprehensive data security plan that aligns with the relevant guidelines, such as TCPS2, PIPEDA, and your institution's policy. And also, you want to use strong, unique passwords and updating them regularly. This is essential for securing access to the data. You may want to implement the multi-factor authentication as well whenever possible to further strengthen the security. And you want to encrypt the data both at rest and in transit to prevent unauthorized access. And if possible, protect your network using firewalls, secure routes, and VPNs for remote access. And you want to keep your software, operating system, and devices up to date to prevent any vulnerabilities or potential attack. And when sharing sensitive data, use secure file transfer methods such as SFTP via like SSH key or encrypted email services to protect data during transmission. And for data involving personally identifiable information, anonymization and de-identification steps are essential to protect the privacy of the data. And this involves removing any kind of personal information that could be used to identify the individuals. And regarding backup, one of the best practices for data security is to follow the 3-2-1 backup rule, which is a simple rule and a highly effective strategy for safeguarding your data. So first, you want to have 3 copies of your data. This includes 1 primary copy that you actively work with and 2 additional backups. And the second, store these copies on 2 different types of media. For example, 1 copy can be stored on an external hard drive, and another one can be stored in the cloud. And lastly, keep 1 copy offsite. This means storing one of your backups at a different physical location, like a secure cloud service or an offsite data center. So these backup rules protect your data in the event of local disasters, such as a fire hazard or flooding or theft. Okay, so a special note on the flash drives, if you happen to use these devices. So it's a small, light, easy to carry, and easy to lose. And so here you can see that they can commonly be found at the lost and found, and people have lost their keys because they attach them to the keychain. So I strongly discourage the use of it for data transfer or storage. Okay, so the next I'm going to talk about data sharing and data deposits. So when describing your data, it's crucial to provide detailed and accurate information to ensure that they can be understood, reused, and properly managed. So you want to include the modality of data, whether it's like tabular or staging or it's a sequencing data, etc. And you want to detail the format of the data. So we prefer that it's in an open format rather than proprietary. And the data aggregated or non-aggregated. And you also want to document the level of processing. What will be the processing steps you have for this data from the original data, and the amount of data that there is, like how many files, how big the data set is, and you really want to make sure that the data is uncompressed and then encrypted to make sure it can be easily shared with others. And proper documentation is also a critical step. So you want to make sure that like all the metadata associated with the data set is properly documented. So that includes any taxonomies, ontologies, and controlled vocabularies that are used to describe your data. So the NIH Common Data Elements is a very good resource for finding the relevant data elements, common data elements for your specific field. Miami is for microarray data, and sequence for sequencing data. So these will be good resources to go to when you want to describe your data with the right vocabulary. You also want to include a data dictionary and to define each variable in your data set. So this will be make it much easier for others to understand your data in the future. And the resume file is highly recommended. This include key aspects, including the file formats, data collection methodology, instruments and software use, and the relationship between different files, and any quality control measures you have taken. And then you also want to decide on the level of access. So first of all, data discovery is not equal to data access. You can assign, like for example, DOI to your metadata, and people may still find the description of data, but your data is located elsewhere, and they are not able to access. So these are very two different concepts. And there are also data privacy, security, and ethical considerations. So in Canada, so generally for the preclinical research, so if you're working with like any human-derived preclinical materials such as tissues, cells, and organoids, and also maybe personally identifiable like genome data, then you need to comply with these policies. So generally for the government, it will be the Tri-Council Policy Statement, Ethical Conduct for Research Involving Humans, TCPS 2, 2022. And there may be any policies from the Ethics Board and your institution. And also there's consideration for if you're working with any data involving with indigenous populations. And if the data is associated with any consent forms and data use agreement, you will also need to check those terms as well to make sure you are following the right guidelines and not violating the terms. And if there are any restrictions related to data provenance, you need to check as well, because sometimes maybe the data you're using is not the original data, using the secondary data from someone else. And there might be some consent form that the use agreement associated with those original data. So really want to make sure that you check those forms and restrictions as well, and to make sure you comply with all the policies. And for all your data, that's to be shared, you want to make sure that you assign them with a persistent identifier. And one of the example would be DOI, Digital Object Identifier, which is a globally unique persistent type of URL assigned to a digital resource by identifier registry, for example, like a DataCite or construct. So, so the rationale behind this DOI is that, or PID in general, is so one, it needs to be globally unique. So this number, it doesn't matter where you are in this world, this number will represent your data set. And it needs to be persistent. It needs to be long-term. So that's why we use the DOI from these sources, because they kind of promise like the long-term storage of these numbers. So you want to make sure that in the future, even if your data set is lost, these numbers would still describe your data alone. And there are some DOIs specific to biomedical research, for example, NCBI accession number, PMCIDs, and ensemble genome identifiers. And to attribute to the right people, the authors for the data, generally we would recommend to you include their like ORCID ID. So these are unique identifiers that link researchers to their scholarly outputs. And also for any kind of like a concepts and a wording, you really want to follow the right ontology, the right control vocabularies. And for example, you can use the medical subject headings, or let's say for certain taxonomy, you can use Uniprot names. So how can people trust that the data they downloaded is the data set that's being described and that the data set is not corrupted? So you want to do the fixity and the completeness check. So the completeness check basically is like checking how complete your data is based on the structure, for example. So one example would be the dimension check. Let's say for tabular data, it's going to check how many rows there are, how many columns there are, just to make sure that the data is the same as the original data. And then we can have a fixity check. So fixity check basically is different kinds of algorithms like SHA, MD5, checksum. So this algorithm basically convert any kind of digital data into like a consistent list of like digits or numbers. And then basically they just match these numbers with the original file to make sure that the files are identical. So you really want to make sure you do these checks after you share your data to make sure nothing's changed or corrupted. And also you want to add the lessons when you're sharing your data. So this may contrary to common sense. Like let's say if you don't add the lessons and you deposit your data to a repository, it doesn't mean that like anyone can just use it freely. So it's actually kind of like a gray zone. And in some countries, if you don't add the lessons, it means all rights are reserved. You still have the ownership of the data. Other people cannot just use it right away. So if you want to freely share your data, generally the recommendation is you add like CC0. So CC stands for Creating Common. They have a list of different licenses you can use. And if you want certain restriction for them to use your data, you can add other licenses. For example, CC by Y. That means they can use your data, but they need to acknowledge the contributor of this data set. So if you're interested in reading more about the licenses, check them out. And how do we pick a suitable repository? So one approach is to look for a discipline-specific repository because fellow researchers with similar research aims are more likely to look into those repositories for data for reuse. Also, you can there are some journals that would recommend certain repositories. So here I have like a list of repository registry and journal recommendations that these institute organization they recommend certain repositories. And we will also recommend you use you can also use like a general repository as well if your data set is very large. So they generally offer broader accessibility and a good choice for interdisciplinary research. And we would also recommend you use institutional repositories because these repositories provide added advantage of compliance with both your local government and your institutional regulations. And they also ensure long-term storage and have institutional support as well. So these are a list of general repositories. And here at the BHI, under the leadership of Dr. Kelly Kobe and Dr. Joy Edwards, we are building a data portal called Archimedes. That's going to address the tri-agency data deposit requirement. This portal enables storage and sharing of large multimodal research data, including levels of restricted access, and supports automated data visualization and analytics through high-performance cloud computing. So this product is in the process of piloting use cases. So if you would like to participate in the process or have any questions, please do not hesitate to reach out to us at any time. And here, finally, I will present a real data set from a BHI group and discuss how it aligns with the FAIR principles for data sharing. So we are very grateful to receive data sets from Dr. Ruth's Select Lab. So these are single-cell RNA-seq data. So here's kind of like a brief description of the study that they examine the stem cell neurogenesis in the subgranular zone of both control mice and the triple transgenic mice carrying Alzheimer-related human genes. And by leveraging the power of single-cell RNA sequencing, the expression levels of tens of thousands of genes were determined for each individual cell. And then using a dimensional reduction algorithm, UMAP, this UMAP plot clearly highlights distinct clusters of various cell types based on gene expression levels, and which effectively demonstrating the isolation of the stem cell that we're looking for. So so in the study, they demonstrated like that there is a reduction in neurogenesis in the stem cells for the transgenic mice that has the human disease Alzheimer's genes in them. So these are the detailed guidelines of FAIR principle. So in the next few slides, we will walk through how the data can be deposited and made fundable, accessible, interoperable, and reusable following the FAIR principle. So this single-cell RNA-seq data has already been deposited in the Gene Expression Omnibus, GEO, which is a common repository for RNA-seq data. However, it is in embargo. And also the data is in the process of being deposited in the Archimedes portal as well. So this data is currently under embargo, so it's not accessible on the website. So for the demonstration, I will use data from a previous study that utilizes the same genome type and includes RNA sequencing data as well. So here for fundable section of the FAIR principle, metadata assigned with a globally unique and persistent identifier, and F3 metadata clearly and explicitly include the identifier of the data they describe. So here we can see that for this study, there is a GEO accession number being assigned to the data. So that follows this FAIR principle item. And F2, data are described with rich metadata. So here, from this description of the data set, we can see that the platform of the sequencing is being described, and the samples were described in detail. So there are rich metadata associated with this data set. And for metadata registered or indexed in a searchable resource. So here on the GEO website, when we search using this accession number, we're able to find the data right away. And also, if we search using the genotype 3xTG-AD, we are also able to find this data as entry number 8 in the index. It's also best practice to search for the data across other dataset search engine as well to make your data as discoverable as possible. And for the A1 accessible item, metadata are retrievable by their identifier using a standardized communication protocol. The protocol is open, free, and universally implementable. Yeah, so here the accession number can be equivalent as communication protocol here. And for the interoperable, metadata use a formal, accessible, shared, and broadly applicable language for knowledge representation. Metadata use vocabularies that follow FAIR principles, and reusable metadata are richly described with a plurality of accurate and relevant attributes. So again, this is talking about the richness of metadata. So here we can see the organism is described using the proper ontology, and also the sequencing method is also described using the right terminology as well. And reusable 1.1 metadata are released with a clear and accessible data usage lessons. So here, the lessons is not a built-in feature on the GEO. So some other repositories offer more robust functionality that allow users to attach lessons to their data set. So this is something that like GEO can improve, and because this lessons is a key step for the verification of the data. And R 1.2 metadata are associated with detailed provenance. So it's very important to document where the data come from, this origin. So here we can see that we can see the contributor's name. We can also see the citation of the publication. But some other repositories would also allow the users to attach their protocol and to indicate their orchid ID, which are also kind of important for the provenance of the dataset as well. And reusable 1.3 metadata meet domain relevant community standard. So GEO use a format called a simple anonymous in text format soft, which is a compact simple text format that incorporates experimental data and metadata. So the file looks something like this. And so we checked this document and see that it follows the MINISIX standards. So MINISIX standards define the minimum information required for a high throughput sequencing experiment. So therefore, this data set described is in detail and comply with these community standards. Okay, and that concludes the presentation. Thank you so much for your attention. And if there are any questions, please feel free to raise your hand. Questions? Yes, we will share the presentation afterwards. We will share the slides in the chat.
Edward, thank you very much for the presentation. Actually, it was really good. Can you hear me?
Yes, I can hear you.
Yeah, so in this case, you are giving examples of large data, especially genomics, that generate lots of data. I work in a field that I do not generate so much data, let's say in the range of less than 100 points for one experiment. So what's the recommended pathway to reposit this data under these standards? Is there any idea how you can advise on that?
Yeah, so large size of data is more like a limitation that only certain repository can handle. But all of these repositories can handle, like, let's say if the data is not large, so there's definitely capacity for that. So for your data, I just want to make sure you kind of follow all these best practice to properly document and properly organize and really make sure you send the correct metadata, the right vocabulary with this data, and then you could deposit in one of the repositories. So we really suggest like anything that's specific to your discipline. So I'm not sure which area your data is, but there could be some certain repository related to your discipline. And also we recommend institutional repository. Especially for the BHI, we are designing something that's made for like all-purpose kind of data portal that's going to be very useful for deposit different kinds of data as well. So if you have any questions, I would suggest you also reach out to us afterwards, and we can look specifically at your data set and how to best deposit your data for to make it fair, right, for other people to discover your data and collaborate with you.
Oh, perfect. Thank you very much, Edward.
Yeah, thank you.